Good morning, class. So today we are going to start the last part of the electricity unit, and I'm going to be talking about generating electricity. And at the end of this lesson, you're going to be given an independent assignment, basically a small project, and there will be some choice. And but before I assign the project, I would like to go through this PowerPoint with you. So you already know that Canadians use over 2 times 10 to the power of 18 joules of electrical energy every year. And so where does all this energy come from? Within Canada, the energy basically is harnessed by a number of different phenomenon. Canada uses the harnesses rapidly flowing waters. There's the burning of fossil fuels and splitting of atoms to release nuclear energy. Okay, and there are different sources of energy, but basically they all have something in common, which is basically the fact that they're all using kinetic energy. And so there's, for example, if we're talking about the flowing water, the flowing water basically is directed to a reservoir, and eventually it goes to a turbine, and the high pressure of the water basically turns this turbine, which then turns a generator, and the generator will convert that kinetic energy, that movement energy, into electrical energy. And basically this is sent out and connected to what is called a step-up transformer, because it needs to, the amount of energy needs to be increased so that it will eventually go through those power lines and into your homes and offices and schools. But before it goes through into your homes and other buildings, there's another transformer that decreases the amount of energy. And we'll talk about that later. So there's different types of sources of energy, and but they all basically have this in common, in terms of there's a power station in which, for coal, oil, and gas, water is heated, and that steam that is created causes this turbine to turn, and eventually this causes this generator to allow for the kinetic energy to be converted into electrical energy. So that's what we're going to be looking at today. So key question: what pathway does electricity take to get to that outlet that you have in your homes and your schools and offices? We're going to compare and contrast the different sources of electricity and be able to identify and describe the path electricity takes from the generating station. So, meeting the demand for electricity, a lot of planning is required in order to make sure that within Ontario, we're speaking, that Ontario has the ability to provide enough electricity to meet the demand of electricity. And this term right here, base load, refers to the continuous minimum demand for electrical power. So that is the minimum demand for electrical power. So in this graph here, you can see that for a 24-hour day, the base load is this purple. This is being this is basically just producing that a little over 10,000 megawatts of electricity, and then over that there's renewables are being used here, including that's hydroelectric electricity within Ontario is producing that electricity, and then over that you go into solar, and then also natural gas. Okay, so this is all being produced by, most of the energy in Ontario is produced by nuclear. Okay, this is the nuclear energy provides the base load, the minimum demand of electrical power. And then in Ontario, it's called the Independent Electricity System Operator, or ISO, which manages the transmission and distribution of electricity within Ontario. And basically, Ontario's current installed generation capacity includes the following. So most of it, as you can see, is nuclear, which is 61%, then hydro 25%, gas and oil 6%, wind energy 7%, biofuel is really, really small, 1%, and solar is very, very, very small as well. So about 15%, I think I would say. Or sorry, not 15%. That's not 15. Obviously, that's less than 1%. So there is within Ontario, not all provinces have this. We're so lucky. I'm being sarcastic here, that we have to worry about what time we use our electrical loads within our homes, because of the fact that the price of electricity will vary within the day depending on what the season is. Okay, so this is a diagram here that shows you the winter time of use hours in effect. So electricity prices for November 1st, 2019. So off peak, which is this green color, it costs 10.1 cents per kilowatt hour, compared to on peak, which is more than double the cost, 20.8 cents per kilowatt hour. So if you look over on here, these colors coordinate with these clocks, I would say. So on a weekday, this is how you would calculate how much the electricity costs you when you're using, for example, any of your electrical appliances, like the small things that really doesn't matter, like a light fixture, but something like a clothes dryer, dishwasher, stove, air conditioner, they take consume a lot of electricity, so you have to kind of be careful. So it says here, according to this diagram, so from 7 p.m. to 7 a.m. it is off peak time. Okay, so the cheapest time to use any of your appliances would be from 7 p.m. all the way to 7 a.m. And then after 7 a.m. in the morning up until 11 a.m. in the morning, it is the most expensive, or one of the most expensive times. So these 4 hours over here, and 2 hours in the evening this is 5 to 7. So this is basically when everybody is at home, they're using electricity, they're cooking, And if you're cold, you're going to turn the heating up higher because this is winter hours. So this is where it becomes more expensive, and they want you to reduce the amount of electricity that you're using. So this is the most expensive time. But on weekends, luckily, there is no peak hours. Okay, it's basically off peak for the Saturday and Sunday and all holidays. Okay, which is a nice thing. So the same thing happens for summer, except it's a little different. You can see that off peak now is still from 7 to 7, but you have the most expensive is not from 7 a.m. to 11 noon. It's actually from 11 noon to 5 p.m. Okay, and it's cheaper. Off peak is cheaper, if you can see that. So it's here 10.1 cents per kilowatt hour. In the summer, or from May 1st to October 31st, its off-peak time is 6.5 cents per kilowatt hour. So that's just to show you that within Ontario, we get charged a lot of money for using our electrical appliances during the week compared to other provinces. Okay, and it depends on the season, depends on the day of the week as well. So generating electricity, and an energy source is basically any resource that can be used to generate electricity. The energy source is used to spin the shaft of a generator, which causes a coil and a magnet to move relative to each other. And this motion generates an electrical field that causes electrons to move. Okay, so this is a diagram of hydroelectric power generation. This is you're increasing by creating this dam, you're increasing the height. There's a height difference between the upstream and the downstream water level. And so water will, when it goes through this channel, which is called a penstock, it will have a much higher flow of charge. And basically that flow is used to turn this turbine, which will eventually cause the generator to function as well, eventually creating that electrical field, which is transmitted into these wires from the generation powerhouse, the power plant, and then eventually into a transformer, which increases the current, and then eventually to those power transmission cables that go to your houses and buildings and offices. So energy sources are divided into two different categories. We know them as renewable and non-renewable. A source that is non-renewable is one that cannot be replaced as quickly as it is being used. And a source is renewable if it can be replaced in a relatively short period of time. So non-renewable sources work by thermal generation, generating electricity by basically heating water to produce steam, which spins a turbine. And non-renewable sources, such as fossil fuels, including oil, coal, and natural gas, they are cheap, but one of the issues, and you're going to research this if you choose this type of source for your project, causes a lot of other environmental issues, including pollution. Non-renewable sources, for example, nuclear power, it works by using radioactive materials to heat the water. Okay, so for example, uranium atoms, thermal nuclear generator will use uranium atoms, which are basically split into smaller atoms, producing a huge amount of energy. And this energy will also cause a turbine to spin, which turns a generator that produces electricity, and so nuclear power can generate a lot of electricity, but once the radioactive materials are used, they remain dangerous for tens of thousands of years. So again, a source is renewable if it can be replaced in a relatively short amount of time. Common renewable sources of electricity include hydroelectric, wind, solar, tidal, biomass, and geothermal. Hydroelectric generating stations work by using the moving water to spin turbines again. Hydroelectric dams do not create pollution, but they do have negative impacts on the surrounding ecosystems. Windmills use the wind to spin blades to generate electricity. Again, windmills do not cause any pollution, but there are problems associated with windmills as well. They are known to cause people that live within within the vicinity to have migraines, to have other nervous system issues. They take up a lot of space, so a lot of land is being used, and even though they don't create pollution, they do have they can have a negative impact on the surrounding ecosystems as well. They kill a lot of birds, for example. In solar, which is another renewable source, materials are struck by light, generating an electric current. This is known as the photovoltaic effect. Solar energy can be scaled easily. However, when you are installing your panels for producing large-scale solar energy, the panels themselves are very, very expensive and not very efficient. So these are just some examples, and you're going to be looking at some more for your project. So moving electricity. So basically, to go from a generating station to your home, electricity must travel on what is known as the grid. Okay, so once electricity leaves the generation, it enters a step-up transformer where the potential difference of the electricity is increased. So voltage is increased, but as it nears your home, the electricity enters a step-down transformer to decrease the potential energy. So here's your example: power generating station. The transformer steps up the electricity to 500,000 kilovolts, and then there's another substation here that reduces that to between 60 to 138 kilovolts, and then that goes to a distribution center, which also reduces that potential difference to about 25 kilovolts before entering into the home. I've included a little video for you guys to watch that might be helpful. It talks about exactly how the electricity generation takes place in terms of the generator and the turbines. You may want to take a look at that. So, and there's also reading in your textbook from page 500 to approximately 512, and it talks about the different types of renewable and non-renewable sources of energy.